Dear students, this is Dr. Biju Vasudevan. In this video, we will discuss chapter 12.3 Fourier cosine and sine series. In the last chapter, we have discussed Fourier series of a function f of x in the interval negative p to p. When we are asked to find Fourier series, we have expanded the given function in both the cosine and the sine series. There will be a constant term a0 over 2. There will be a cosine part, cosine n pi x over p along with the an. Another part is sine part, isn't it? bn sine n pi x over p. There are three parts. Now, if you are asked to expand Fourier cosine series, you will find only first two terms in this chapter. If you are asked to find sine series, only second part will be there. First two parts will not be available. So the reason is explained here in the chapter why we are going to do so. First, we should understand the basics of even and odd functions. So a function is said to be even if f of negative x is equal to f of x. For example, f of x is equal to x square is an even function. Take negative x square will be again x square, isn't it? But f of x, which is x power 3, is odd function. So this is an example of even function, this is an example of odd function. F of negative x is negative x whole cube will be negative x cube, which is negative times f of x. This is f of x. So that's the difference between odd and even function. We know cosine x is even, sine x is odd. So if the function is given to be even function, then we will expand obviously the given function to cosine series. If the given function is a sine, an odd function, then obviously its expansion will be a sine series. So the question of odd and even arises when the interval is symmetric, negative p to p, negative 1 to positive 1, negative infinity to positive infinity, negative 2 to positive infinity 2. In this case of interval, the question comes whether the function is even or odd. What are we going to do with this information? See, identify some rules. The product of two even function is even. Yes, multiply x square and x square. This x power 4 again even. Product of two odd function is even. Yes, multiply x cube and x cube. It will be x power 6 even. The product of an even and odd is x square into x cube is x power 5, which is odd. Sum or difference of two even function is even. X power 4 minus x square is even function. Sum or difference of two odd function is odd. X plus x cube is odd. So the important point comes here. If f is even, integration from negative 2 to positive 2 f of x dx can be written as 2 times 0 to 2 f of x dx. Instead of using minus 2 to 2, see, this is the line integration assume. This is from negative 2 to positive 2, 0. Instead of integrating from negative 2 to positive 2, you can start integration from 0 to 2. Write the answer 2 times, isn't it? 2 times integration 0 to 2. This is possible only when f of x is even. Otherwise, if f of x is odd, the symmetric integration will be 0. The function is odd. You can verify this one. Integration of x square dx is equal to from negative 2 to positive 2 is 2 times 0 to 2 x square dx. You can verify. Integration of minus 3 to 3 x power 5 to dx is 0. So the interval is symmetric from negative 3 to same number and the positive sign upper limit. But the function is odd, the integration should be 0. These two are the very important properties that we are going to use here. So what happens in the Fourier formula? That's the question here. What happens in the Fourier? This is the formula, isn't it? So when the function Fourier series of an even function in the interval negative p to p, what happens? Why bn is 0? Why only a0 and an are available? Bn, what is the formula of bn? My function is assumed to be even, isn't it? Bn formula is 1 over p integration negative p to p f of x sine n pi x over p dx, isn't it? F of x is even, given here. Sine is odd, and we know the product of odd and go back here, you can see the product of odd and even function and odd function is odd. So the product of f of x and the sine will be odd. So when you integrate an odd function from negative p to p, the answer is 0. Therefore bn will be 0 for even functions. Similarly, you can check an and a1 a0 will be 0 if f of x is odd. F of x is odd function from negative infinity to positive, negative p to positive p, integration is 0 for a0, isn't it? When you multiply odd function with the even function cosine, again the output is odd function. So integration of f of x cosine n pi x over p dx from negative p to p will also be 0. Therefore an and a0 will be 0 when the function is odd. In the case, we have to find only bn. And what happens in bn? The formula is slightly different. Instead of negative p to p, they have written 2 times 0 to p. 2 times 0 to p. That's all. 2 times 0 to p. Okay. So remember these formulas for cosine, Fourier cosine and sine series. Next is half range expansion. Assuming that given is half range. Actually, I'm giving a function f of x. F of x is equal to x in the interval 0 to L. L can be any number. 0 to L in the interval 0 to L. I'm telling that find half range series. HR series, half range series. Then immediately you should understand the given length is half range. Half interval. So full interval is negative L to positive L. Negative L to positive L. Therefore, the P is usually 0 to L, isn't it? The half length is P. So P is L. Given is L. Given is half range. Okay. So this is called half range range. So what happens? We can convert this one into either odd function or even function, depending upon the requirement of the question. If they are looking for half range sine series, we have to assume that we have to construct the other part of f of x in the interval minus L to 0 such that the output will become f of output leads to the conclusion that f of x is an odd. What is the case? How do you do it? See, f of x is equal to x is a straight line passing through the origin, which is 45 degrees. This is f of y is equal to x. If I consider another part in this side, this will become even function. If I extend this one in this direction, so it will become an odd function, isn't it? It will become, so it's depending upon how we extend. If we extend this side, it will be just a reflection about x-axis. Okay. So how we extend the given part in the opposite direction? We can make the f of x is equal to x, and we can extend it in the other interval as this f of x is odd function or even function. It is possible. If I write f of x given is x in the interval 0 to L minus x, I am taking in the interval minus L to 0, this becomes modulus x and it's an even function. And if I write both the sides f of x, it's an example. If I write f of x is x on both the sides, it will be an odd function. So any given function in the half range can be expanded in the other opposite side direction, isn't it? As the function as an even or odd function depending upon the case. That's what here. In general, they have told us half range series. So if the question is half range sine series, we assume the opposite side is, we don't need to construct the function, we assume the opposite side is also so that the function is odd, and we go ahead with the previous formulas. This one, odd function, we will find only sine series using this formula, right? And if you are looking for half range cosine series, we assume the other part of f of x such that the f of x is an even function, and we don't need to consider, actually we assume that other part is falling in this area, so it will be an even function, isn't it? And then we find a0 an by using these two formulas. Now use this to find the cosine series expansion. So formulas are the same formulas for cosine and sine series, right? But if you are not asked to find a half range series, then it should be considered full range. Then your P will be L by 2. If not a half range series, then this will be full range, then P should be L over 2. That is different case, right? Just general case, that is one. Okay. Here some explanation is given. This is the given function. It has been expanded on the left side, so that is looking at even function. If you expand the same function in this way in the left side, in the symmetric interval negative L to 0, it becomes odd reflection, isn't it? This is identity reflection, the same reflection, scaling, translated few units. That's all. Now, some exercise problems. Determine whether the function is even or odd. That's what we are going to do. We know how to verify these three functions very easily. 1. Take f of negative x. We know sine is odd function. It is minus sine 3x. So minus times f of x. This is odd. Second, take f of negative x. Negative x cube minus 4 times negative x. It will be negative x cube plus 4x. Take negative outside. X cube minus 4x. So this is negative f of x. Odd, because they are the difference between two odd functions. So again odd. Finally, if problem number 5. What do you think? F of minus x is equal to f of modulus minus x. Again it will be e power x, which is f of x. Therefore it will be even function. 5 is an even function. Now the question is, when the function is defined piecewise, how to verify? If I give you f of x is first part h1x, second part h2 of x, in the interval negative p to 0 and 0 to p, a function will be defined piecewise in this way, right? And take h1 of negative x. If it is h2 of x, we call it even function. Okay, if you take the first function h1 of negative x but ending with negative h2 of x, second part is, isn't it? You call it odd function. You call it odd function. That's it. take the first part, substitute x as negative x, and check what you get. If you end up with the second part without negative sign, you are dealing with the even function. But if you end up with the second part with the negative sign outside, the function given is an odd function. Clear? That's what we are going to do here for these two problems. F of x is given. So what is h1 of x? h1 of x is x square. h2 of second part of this piecewise function is negative x square, right? Okay. Take negative x in the first function. What happens? This minus x square. Minus x square is x square, isn't it? So what is it? How can we construct x square here, a second function here? We can write this one as negative times negative x square, isn't it? Square is for only x. So this is a negative, this part is second function, h2 of x square, h2 of x, right? What is it? When you take first function with the negative inside, it is negative is out and it becomes second function. Therefore, this is odd function. The given f of x is odd, right? Similarly, check 8. What is the first part? h1 of x is x plus 5. h2 of x is minus x plus 5. Now take the first part with negative x. It becomes negative x plus 5. Negative x plus 5 is nothing but your second function. So there is h2 of x. This says that the given f of x is even function. And the answers are given here. Expand the given function in an appropriate cosine or sine. See, check if the function is even, you expand into cosine series. If the function is odd, you will expand into only sine series. So half of the work should be done for Fourier series. Okay. We'll start. Problem number 11. Given as a space-wise defined function, take h1 as h1 of x is a constant function pi, h2 of x is a constant function negative pi. So whatever the x value, the function output is pi. Here the result is negative pi. So h1 of negative x is also pi, which is negative of negative pi, which is negative h2 of x. We can call f is odd function. So given function is odd function. Therefore, what do you get? a0 and an are zeros. We will find only bn by using the formula 2 over p. 2 times 0 to p we will write, not in minus p to p, isn't it? We have to find bn, so this is f of x sine n pi x over p dx, and give the interval is minus p to positive p, isn't it? So the p value is 1. Substitute the p value here. So it will be 2 outside, 0 to 1. F of x in the first 0 to 1, in the interval 0 to 1, f of x is negative pi. negative pi sine n pi x dx. Therefore minus 2 pi is constant outside. When you integrate sine, you will get negative cosine n pi x over n pi from 0 to 1. So this minus and this minus will be positive 2 pi divided by n pi. N pi is in this geometry. Now substitute upper limit x equal to 1. Cosine n pi is minus 1 to the power n minus cosine 0 will give you 1. So this is your bn. That's all. When you simplify, bn becomes, writing here, bn becomes pi can be cancelled, 2 over n minus 1 to the power n minus 1. You can write this one as 0 when n is even and minus 4 by n when n is odd. It is possible because when n is odd, minus 1 to the power odd number will be minus 1, minus 1 is minus 2, minus 2 into 2 will be minus 4 over n. Is it possible? Now what is the function f of x? First part a0 is 0, an is 0, third part summation n from, see we are taking n is odd, n is from 1, 3, 5 is going up to infinity, and the bn value is negative 4 over n sine n pi x divided by 1. That is the end of this problem. This is the Fourier series. The second problem is problem number 20. Problem number 20 that will be solved. Let's try in the same page. So f of x has been given here. Check it is odd or even. First part h1 of x is x plus 1, h2 of x is x minus 1, isn't it? H1 of negative x is negative x plus 1, which when you take negative outside it will be x minus 1, which is negative h2 of x. Therefore this given function is an odd function. What is the given function? F of x is an odd function. Therefore a0 and an will be 0. Only to find bn, the formula is 2 over p from 0 to p f of x sine n pi x over p dx. This p is in the theta, right? What is p here? Again p value is 1. Therefore 2 times 0 to 1. In this interval 0 to 1, what is the function value? Function value is x minus 1. Because we are dealing with the interval 0 to 1. Sine n pi x dx. Okay. So when you use integration by parts, u is x minus 1, u prime is 1, u double prime is 0. V is sine n pi x, v1 is minus cosine n pi x over n pi, and v2 is minus sine n pi x over n pi whole square. So when you substitute all the elements here, you get 2 is outside, minus x minus 1 cosine n pi x over n pi plus sine n pi x or n pi whole square from 0 to 1, because the formula is integral uv dx, the different version of integration by parts when u is an algebraic function, which is u v1 minus u dash v2 plus u double dash v3 is going on, right? So this part onwards everything is 0, you have only two terms. So u is x minus 1, b1 has been given here, that's the first term, and u prime is 1 with v2, which is here, minus and minus, it will be plus. Okay, now substitute upper and lower limit. What do you get when 2 is outside? When x is 1, the first term will be 0, second term will also be 0, so upper limit is 0, there is nothing, upper limit gives you zeros. When x is 0, this part will be 0, sin 0 will be 0, but here you can find some answer. X is 0, minus 1 will be positive 1, cosine n pi, cosine n pi, x is 0, cosine n pi 0 is cosine 0, cosine 0 is 1 over n pi, so the answer is minus 2 over n pi. Therefore what is your bn? Bn is minus 2 over n pi. Therefore what is the Fourier sine series? F of x, first two parts are 0, summation n from 1 to infinity bn is minus 2 over n pi into sine n pi x. That's the end of problem number 20. Only one more question. This one, is it looking even function? Yeah, I know that this is even function. That is verification is necessary when, see, we need to know whether the given function is even or odd if the interval is symmetric from negative pi to pi. If I give the interval 0 to pi or 0 to 2 pi, there is no need to verify. You have to find general Fourier series, right? Unless otherwise specified as half range series. So now we are solving 23, and we know that this f of x is even function. You can write f of x negative sin x in the interval negative pi less than x less than 0, sin x in the interval 0 less than x less than pi, isn't it? Now it's looking like modulus x, the formula of modulus x, which is when it comes under modulus sign, obviously it's an even function, right? And why should I write here this part is, in the interval 0 to pi, f of x is sin x, not negative sin x. So when it is even function, bn is 0, but there is a0 is 2 over p integration 0 to p f of x dx. So what is f of x? 2 over p. What is p here? P is half length, so p is pi, integral 2 over pi 0 to pi f of x in the interval 0 to pi is sin x dx. When you integrate sin x, you get minus cosine x from 0 to pi, 2 over pi, there is negative outside, cosine pi is minus 1 and cosine 0 is 1. So this is minus 2, the answer is 4 over pi. The answer is 4 over pi. Now this problem needs to be addressed for bn. Should bn? No, bn is 0. We have to find an. Okay, we'll go for a worksheet. And remember what's the value of so we have found here bn is 0 we got, and we found a1 is minus 4 by pi. Is it minus 4 by pi or positive? Yes, positive 4 by pi. It's not minus. Okay, the other part of this problem is to find an. The formula is 2 over pi, because it is p is pi, from 0 to pi. In this interval, function is sine x, and function along with the cosine n pi x over pi dx. So you will get 2 over pi outside, integral 0 to pi sine x cosine nx dx, and we have a formula for 2 times sine a cosine b is sine a plus b plus sine a minus b. You remember this formula? Use here, 2 is outside, so 2 times sine a cosine b, 1 over pi. It becomes, under integration 0 to pi, it becomes sine a is x, so x plus nx. You can write 1 plus n times x plus sine 1 minus n times x, isn't it? Now dx. After integration, you will get negative cosine 1 plus n times x over 1 plus n, again negative cosine 1 minus n times x divided by 1 minus n 0 to pi. Now substitute the upper and lower limit. X will be replaced by pi and x will be replaced by pi. Upper limit gives an is equal to, take negative out from both the terms, isn't it? So what do you get? Negative 1 over pi. Then upper limit, when you substitute x equal to pi, first term will give you minus 1 to the power 1 plus n divided by 1 plus n. Second term will give you minus 1 to the power 1 minus n divided by 1 minus n. This is for upper limit. Now go and substitute x equal to 0. Then cosine 0 is 1. Cosine 0 is 1. 1 over n, 1 plus n minus 1 over 1. 1 over 1 plus n plus 1 over 1 minus n. This is for lower limit. So we take a minus outside. From this one 1 minus outside, from this one 1 minus 1 outside, from this one this negative outside. So when you take a minus 1 outside, the first term will be minus 1 to the power n over 1 plus n. Second term will be minus 1 to the power minus n. You know, minus 1 to the power minus n is equal to minus 1 to the power n. You can check, it will be 1 over minus 1 to the power n. There is no change going to happen. They are equal, right? You can write in next step 1 minus n. This will be plus 1 over 1 plus n plus 1 over 1 minus n. Now I club these two together because they have same denominator, and the outside it will be positive 1 over pi. When the denominator is common for 1 plus n, the terms are 1 minus 1 to the power n plus 1. Similarly, for this denominator 1 minus n minus 1 to the power n plus 1. Now the common term is minus 1 to the power n plus 1 outside over pi. inside the bracket you will get 1 over 1 plus n plus 1 over 1 minus n. When you simplify, minus 1 to the power n plus 1 will be outside over pi. Inside it will be cross multiplication. 1 minus n plus 1 plus n divided by 1 square minus n square. So at the end the answer is an is equal to 2 over pi minus 1 to the power n plus 1 divided by 1 minus n square. What happened now? This term becomes minus n plus n will be cancelled, 1 plus 1 will be 2, that's it. This can be further written as when n is odd, what do you get is 0. Odd will give this one negative 1 plus and positive 1 will be 0, isn't it? When n is even, this will be positive 1 plus 1 positive 2 2 into 2 4 over pi times 1 minus n square. Now this result is not good for n is equal to 1 because n is equal to 1 will make denominator into infinity and into 0, therefore n will become infinity, so it's not possible, isn't it? So find a1 separately. In the formula of an, take n is equal to 1. This a1 2 over p is pi from 0 to pi. Function is sine x in this interval and cosine nx will be cosine 1x dx, and we know 2 times sine x cosine x is this 2 along with the sine and the cosine. 2 sine x cosine x will be sine 2x. So integration 0 to pi sine 2x dx. That is 1 over pi. Derivation of sine will be minus cosine 2x over 2 from 0 to pi. Mm, 1 over pi upper limit negative, upper limit cosine 2 pi will be 1 minus cosine 0 will be 1 divided by 2, so 0. So a1 is 0, and we know that this is even function, therefore bn is also 0. We got a0 as well. We got a0. What is our a0? A0 is pi by 4, not a1. 4 by pi. Okay, then f of x. For even function it is a0 by 2, that is a1 but which is 0. Then summation starts from n equal to 2 to infinity cosine an into cosine n pi x over p. a0 is 4, a0 is 4 over pi divided by 2, and a1 is 0. Summation n from 2 to, because an is true for only even values, isn't it? So 2 4 6 is going up to infinity. An value is 4 over pi into 1 minus n square, then cosine nx, because p is pi. That's the end. You can simplify further. It is 2 over pi plus summation n from 2 4 6 to infinity 4 over pi into 1 minus n square into cosine nx. That's the end of this problem. Now problem number, we will go to the next problem. We have solved these three problems, found either cosine or sine. Now find half range series, half range cosine and sine separately. So the given is half range 0 to 1, 0 to half and 0 to 1. The entire range is half range. 0 to 1 is half range. Half range. What is full range? Minus 1 to positive 1 is full range. And what is P? P is obviously 1. P is obviously 1. So we need to find A0, AN for cosine series and Bn for sine series. So we will find all the terms because they ask both the terms. If they ask only half range cosine series, we end up with only two terms. If they ask only sine half range sine series, we will find only Bn, and we will write just like the previous problem. Okay. But in this problem, they asked both the series, so obviously we should find all the terms. But using the formulas of even and odd functions. A0. Let's start finding A0. The formula is 2 over P. P is 1. Integration 0 to 1. The function, but 0 to 1 when you write, it should be separated from 0 to half and from half to 1. Half to 1, the function value is 0. So in the interval 0 to half, the function value is 1 dx. When you integrate this one, you will get 2 times x from 0 to half. It will be half minus 0. Half times 2 is 1. So A0 is 1. Next is AN. 2 over 1, integral 0 to 1. It should have been 1, but up to 1 there is no function. Function is available only up to half. Up to half, and the function is 1 cosine n pi x divided by 1. N pi x divided by 1. That is the theta, and dx. Integration of cosine will be sine n pi x divided by n pi from 0 to half. The outside it will be 2. When you substitute upper and lower limit, 2 sine n pi by 2. So 2 over n pi. When you substitute upper limit, it will be sine n pi by 2. Lower limit will be 0. So this is b an. In a similar way, find bn. 2 over 1, 0 to half, function is 1 sine n pi x dx. Therefore it's 2 minus cosine n pi x over n pi from 0 to half, minus 2 over n pi. Upper limit gives cosine n pi over 2. Lower limit gives minus 1. So when you multiply this minus inside, you can write this one 2 over n pi, 2 over n pi one minus cosine n pi over 2. This is for bn. We found all the terms. Now separately we should write, not a one Fourier series. Okay. In this case, finally we will write the answer as, using these two we will write, using the first two we will write cosine series, half range cosine series. Using bn we will write half range sine series. You write it here. Half range cosine series for f of x, which is half a0 by 2 plus cosine series n from 1 to infinity 2 over n pi sine n pi 2, which is our an, and cosine n pi x. Next, half range sine series f of x. First two terms are zeros. Third term is summation n from 1 to infinity 2 over n pi 1 minus cosine n pi over 2 sine n pi x. So this is bn, this is the function. So this is sine series, this is cosine series. In this way we have to solve another function. So we will be back. Now let's solve 34. F of x is equal to 2 times x times 2 minus x in the interval 0 to 2. And you remember we are finding half range sine and half range cosine. So the given is half range. What is full range? Negative 2 to positive 2 is full range, and the p value is 2. We should remember, and we should find both cosine and sine series in this problem. So we should find all the three terms. A0 the formula for A0 is 2 over p. P is 2 from 0 to 2 in this interval. F of x is 2x minus x square dx. So which is, when you integrate this one, you will get 2x square over 2 minus x cube over 3 from 0 to 2. Outside it will be 1. When you substitute upper limit, it will be 4 in the first term minus 8 over 3. That's all. 0 will make everything 0. 12 minus 8 is 4 over 3. A0 is 4 over 3. Next, an. Similarly, 2 over p. P is 2. From 0 to p, p is 2. F of x. F of x. 2x minus x square and cosine n pi x over 2 dx. So use the integration by parts. uv dx uv1 minus u dash v2 plus u double dash v3 and so on, isn't it? U is 2x minus x square. U prime is 2 minus 2x. U double prime is minus 2x. U third derivation, this is 2. Third derivation is 0. So only the first three terms up to u second derivation, isn't it? Fourth term onwards is 0. What is v? V is cosine n pi x over 2. v1 integration of cosine is sine n pi x over 2. v2 integration of sine is minus cosine n pi x over 2. 2 square is here. 2, there is 2 is the constant. The division is n pi over 2. Here it is n pi over 2 whole square. N pi over 2 whole square. v3 is minus sine n pi x over 2 divided by n pi 2 whole cube. You have to use this formula, isn't it? 2 by 2 is outside, gives 2 by 2 becomes 1. This one, u is 2x minus x square times v1. which is sine n pi x over 2 divided by n pi by 2. Second term minus u prime and v2. Minus u prime, v2 is negative, so it will be positive. What is it? It will be 2 minus 2x cosine n pi x over 2 divided by n pi by 2 whole square. Third term is u double dash, which is negative 2, and this is negative positive, so everything is positive. 2 sine n pi x over 2 divided by n pi by 2 whole cube, and it's from 0 to 2. So what is your an? Substitute the upper limit. X is 2 makes the first term 0, second term, so 0 plus 2 minus 4 is minus 2, and cosine n pi 2 by 2 will be cancelled, n pi is minus 1 to the power n, so this will be minus 2 minus 1 to the power n divided by n pi by 2 whole square. And the third term here, x replaces 2 by 2 will become sine n pi is 0. This is for upper limit minus lower limit. X equal to 0 makes the first term 0. X equal to 0 gives only second term. What is it? 0 plus second term will be 2 times cosine 0 is 1. 2 times n pi by 2 whole square, and third term sine 0 will be 0. So we have terms minus 2 to and where to write. Okay, erase some part and then we will write over there. Erase. No, we don't want this part.
Doctor, can we leave now?
So we write the answer here. An is equal to this term. First term will be minus 2 minus 1 to the power n. The common denominator is n square pi square divided by 4, and here it is minus 2, and this 4 goes to the numerator, minus 2 comes out, it will be 8 minus 1 to the power n minus 1 divided by n square pi square, and this minus joins with the minus 1, you get an is equal to 8 times minus 1 to the power n plus 1 minus 1 in the bracket divided by n square pi square. This is your an, and you have to find bn as well. In the similar way you can try bn. I will erase this part. The formula for bn is 2 over 2 0 to 2 2x minus x square sine n pi x over 2 dx. And the similar way, take u is equal to 2x minus x square, v is equal to sine n pi x over 2. Use integration by parts method, the answer will be 16 n cube pi cube 1 minus of minus 1 to the power n, isn't it? So by using Bn we can write Fourier half range sine series which is coming f of x is equal to first two parts are 0, so n from 1 to infinity 16 over n cube pi cube 1 minus 1 to the power n sine n pi x over 2. This is Fourier's sine series, isn't it? And by using an and a0 and a0 is 4 over 3, an is 8 by n square pi square into minus 1 to the power n plus 1 minus 1. We can write Fourier half range cosine series, which is f of x is equal to 2 over 3. 4 over 3 divided by 2 will be 2 over 3 plus an summation n from 1 to infinity 8 over n square pi square into minus 1 to the power n plus 1 minus 1. Now cosine n pi x over 2. This is second answer. The end of this problem. There is one more problem we should solve. This one, 35. Expand the given function in Fourier series, no half range series, isn't it? This is a full range series. So given is full range. What is p? It's not. The given interval is 0 to 2 pi. Therefore p should be half range pi. And we need to find all the terms. A0, the formula is 1 over p, which is pi. Integration from 0 to 2 pi, the entire interval. Function is x square dx. Integrate it is very easy. X cube by 3 from 0 to 2 pi. There will be 1 pi outside. 3 pi is outside. Now you will get 2 pi whole cube, that is 8 pi cube divided by 3 pi. So the answer for a0 is 8 over 3 pi square. And what is the formula for an? 1 over pi 0 to 2 pi. Function is x square cosine n pi x over pi dx. So you will get 1 over pi integral 0 to 2 pi x square cosine nx dx. So uv method, u is x square, u prime is 2x, u double prime is 2, u triple prime is 0. So simply take v is cosine n x, v1 sin nx over n, v2 minus cosine nx over n square, v3 minus sin nx over n cube. Use the formula. U 1 by pi will be out. U v prime v1, u is x square, v1 is sin nx over n minus u prime is 2x, v2 is negative cosine, so it will be positive here, cosine nx over n square. Finally plus, and this will be minus, so here will be minus 2 times u double dash is 2 and v3 is sin nx over n cube from 0 to 2 pi, 0 to 2 pi. So we will continue on the worksheet. what happens when you substitute upper limit. Now we are finding an upper limit 1 over pi outside. Upper limit will give you, see, you want to write the term one more time, x square sine nx over n plus 2x cosine nx over n square minus 2 sine nx over n cube from 0 to 2 pi. Substitute upper limit 2 pi, sine 2 pi n will be 0, cosine 2 pi n will be 1. This is x will be 2 pi, so it will be 4 pi times 1 over n square minus again sine will be 0. For lower limit, sine is 0, cosine nx is 0, it is 0, sine is again 0, all the times will be 0. So an is equal to, this pi will be cancelled with this pi, so you will get an is equal to 4 over n square. Try bn yourself in this way, 1 over pi, and there is 0 to 2 pi. The function is x square sine nx, take u is equal to x square, v is equal to sine nx, and use in the formula, find u prime, u double prime, use the formula u v dx, u v1 minus u prime v2 plus u double prime v3. I think this will be the only 2 second derivation is possible, third derivation will be 0. Choose, and the answer I am writing here for bn minus 4 pi over n. Now finally the answer we have to write by using a0. You can recall what is a0. A0 is 8 by 3 pi square. Using these three we will write the function Fourier series f of x. A0 by 2 summation n from 1 to infinity an cosine n pi, here nx, plus summation n from 1 to infinity bn sin nx. So a0 will be, so this term will be 4 over 3 8 cube, 8 over 3 divided by 2, it will be 4 over 3 pi cube, plus summation n from 1 to infinity 4 over n square cosine nx, plus summation n from 1 to infinity minus 4 pi by n sin nx. That is the end of the Fourier series. Thank you very much.